We're going to be using the fundamental theorem of calculus to help us out here. And what we can see is that FTC is f of b minus f of a is equal to the integral from a to b of f of x dx. So the integral represents the area under the curve from a to b. And f of b and f of a represent the change in the y values. You have to be aware here, it gets kind of stressful, that capital X, capital F, is the function, where lowercase f is the derivative, okay? Just added fun for you. So to solve this first one here, they give me f of 0 is 0, and they want to find f of 3. So I'm going to start by writing an integral of those two things, 0 to 3, of f of x dx, and that's equals capital F of 3 minus f of 0. So filling in right here, I can just see f of 0 is 0, so that's great. That's already settled. Coming over here to look at my graph of lowercase f, I need to figure out what's going on from 0 to 3, and that's this triangle right here. So it has a base of 3 and a height of 5. So I can say area is 1/2 times 3 times 5, which is 7.5. And because that equals 0, we now know f of 3 is 7.5. B, f of 0 is now 4, and they'd like to know f of 5. So now we write the interval from 0 to 5 of f of x dx, and that's equal to capital F of 5 minus f of 0. Always taking the top one as your b minus your a. So f of 0 is 4 this time. And now we're going to do the area over here. We already know that this much is 7.5. We're going to add in this rectangle right there. So I have 7.5 plus 2 times 5, which is 10. So I have 17.5 equals f of 5 minus the 4. I'm going to add the 4 over. And I will end up with f of 5 is 21.5. All right, looking at C, now we're dealing 0 to 4. So we write the integral 0 to 4, and that would be f of x dx equals f of 4 minus f of 0. A little different here that now I'm plugging in the 10 here. Now f of 4 is the 7.5 plus the 5, the area underneath the curve. So then over here, I end up with 12.5 equals 10 minus f of 0. Subtract the 10 over, and you end up with 2.5 equals negative f of 0. So f of 0 is negative 2.5. Okay, the next three you're going to try. Here we go. And the answers are listed. You want to be thinking about the fact of what's underneath the graph. That means that it would be negative. Now, we may not always have a picture. We may have a function. So we're going to start right here. They give me f of 0 is 0, and they'd like f of 2. So write an integral of 0 to 2 of e to the x sine x dx. F of 2 minus f of 0. I can plug the 0 in. At this point in our career, I don't know how to solve this integral yet, so I type it right in the calculator. Going right to the calculus button, taking an integral, and I can see that f of 2 is 5.397. Okay, starting in b here, we're going to go 0 to pi of the same function, and that's f of pi, f of b minus f of a. This is 1. We're looking for f of pi. This is 5.397. I'm going to add the 1 over and get 6.397. 7, and that will be my f of pi. Go ahead and try C. Okay, you were looking for the answer of 0.316. So in example 2 here now, we're looking